How does rocket reusability affect payload capacity? Imagine a rocket that can fly, land, and fly again like a giant space vehicle with a second life. This idea is changing how we think about space launches. But how does making rockets reusable impact what they can carry into space? Let's find out. When a rocket is designed to be reused, it needs special parts to survive the trip back to Earth. These include landing legs, heat shields, and control systems. All of these add extra weight to the rocket. Plus, some of the fuel must be reserved for the return journey, not just for reaching orbit. This means less fuel is available for pushing the payload into space. Because of this added weight and fuel reservation, reusable rockets usually carry about 20 to 30% less payload than their expendable versions. For example, the Falcon 9 rocket from SpaceX, when used multiple times, can deliver roughly 30% less cargo to orbit than when it is used only once. This is a trade-off that engineers accept because reusing the rocket reduces overall costs and turnaround time. The impact of reusability on payload capacity depends on the mission. For low Earth orbit missions, where less energy is needed to reach space, reusable rockets perform quite well. They can still carry a good amount of satellites or cargo, making launches more affordable and frequent. But for higher energy missions, like sending satellites to geostationary transfer orbit or exploring the moon and beyond, the payload reduction becomes more noticeable. In these cases, larger or more powerful rockets might be used instead. To make up for the loss in payload, engineers sometimes build bigger rockets or improve engine efficiency. But these options also increase costs and complexity. For example, SpaceX's Starship aims to be fully reusable and carry large payloads, overcoming some of these limitations. The good news is that reusability lowers launch costs because the same hardware can be used many times. This economic benefit encourages more frequent launches and new space missions. Still, designing a rocket that is both reusable and capable of carrying heavy payloads remains a challenge. It's a balancing act between cost, complexity, and what the mission needs to accomplish. In the end, reusability affects payload capacity mainly because extra hardware and fuel are needed for recovery. This reduces the payload by about 20 to 30%, especially for high-energy missions. But the cost savings and faster launch rates make reusable rockets a game changer in space technology.